Hi dear students, today we start for lesson 4, pages between, we will cover pages between 89 to 94. First I start with a bigger group, changes in matter that mainly divided to two big group, physical changes and chemical changes. But we will focus on the chemical changes in this lesson. But first of all, we need to know what is the difference between physical changes and chemical changes. I think we studied before, and just as a review, the substance present remain chemically same after the physical change. When we have a physical change, the first step, the substance in first step would be same structure, same nature in the last step. As example, water can be formed in the liquid form, the solid form, which is ice, or the gas form, vapor. So all of these form are physical changes. The movement between these form is physical changes, and in all cases, water nature is same. So the nature of water has not changed. So another thing is these changes can be reversed easily. For example, if you have ice, which the ice is consist of water molecule, if you give a heat, can change to the liquid form, that is still is a water. Still is water molecule. So in physical changes, we need to just control pressure and temperature to move to another phase. But the nature of the matter, nature of the substance has not changed. In contrast, chemical changes is different. Chemical changes at the after reaction, we will have a new substance. Like here, there is a reaction between the chemicals, and finally we will have a new substance. And not all of the reaction chemical changes, some of them are very difficult to reverse, and actually some of them are, maybe it's not possible to reverse to the reactants. And there is two type of chemical changes, exothermic or endothermic. Exothermic, that means a reaction or chemical changes which gives you heat or energy. The energy can be form of heat or light or many things, or sound. But the endothermic means the reaction or chemical changes which get energy, like the the chemical changes which you make it on over the heat, like cooking. For example, a cooking, that you are making a food, you give energy in form of fire, in form of heat. So that is the thermic endothermic chemical change. Also, um, cooking is a kind of chemical change, because after that, when you make a new food, you cannot reverse to the ingredient, the initial ingredient, and new substance or new food you will get finally. And also the one point is, exothermic reaction is much more than, there are more than exothermic reaction rather than endothermic reaction. And equation for chemical reaction or chemical changes is like the picture as you can see. We have reactants, that means the initial substance, they are react to each other, then finally the reaction give you products. The substance that you will get is uh, its products. So we know formula of each substance we learned before. The number which is written in below is subscript, and the number which show the multiplication of any formula or any substance is coefficient. Okay, that means coefficient, that means we have two oxygen molecule. Each molecule is consist of two oxygen atoms. Okay, and yeah, this is the question for chemical reaction. And what is the law of conservation of mass? This law tells us each equation must have an equal mass between reactants and products. For example, here we have methane and oxygen, which they are react to each other and they produce carbon dioxide and water. So the amount of mass, okay, the mass for methane plus oxygen, the oxygen which is two molecule, the total number of the mass must be same between reactant and products. That means each reaction will not lose the mass or get extra mass or lose the mass. All are same during the reaction. So we need to make a balance for each equation. We need to have a balanced equation. That means the number of atoms must be same between two side reactants and products. And if the number of atoms are same, if the number of atoms is same, that means the mass, the amount of mass is same in the two sides of each equation. So here, just one note that you need to take is we cannot change the subscript. Okay, we cannot. When we have Fe2, that means two iron atom are connected to each other. So we cannot break the bond. So if you wanna make a balanced equation, you just need to change the coefficient number. This one, 2, 3, 4, 3 here. At the end we have 4 iron in reactants and 4 iron in products. We have 9 oxygen in reactant and 6 oxygen in reactant and 6 oxygen in products. 3 carbon atom is in reactant and 3 carbon also are in reactants in products. So you need to make sure we have same number of for each atoms in reactants and products. Just as a experience that I know, try to, if you want to make a balance between the reactants and products, try to first count the heavy atom, and then after that oxygen and carbon. If we have the hydrogen would be the last atom, to measure. So always try to calculate the number of each atom from the very heavy atoms to lighter atom. The last atom is hydrogen, and here uh, first it counts the iron. The second is oxygen, then carbon. The last one would be hydrogen if you have. So your question, this making balance equation needs to practice a lot. So I put this question as your first question. This is only the question I give you today, and you need to put a suitable number. For example, how many uh, this copper, okay, how many copper we have here, and how many copper we will have in products, which is equal. And also you need to keep in your mind that the oxygen would be same also, and here the nitrogen and ammoniac must be same. This is nitrogen, yeah, nitrogen gas and hydrogen gas. How many hydrogen gas can react with the nitrogen gas that make a same number ammoniac with same number of the similar atoms. So this section need to practice and get experience more. That's all for today. Take care. Thank you so much.